Hello YouTube, Insane J here. The most recent update to Minecraft introduced pistons to the game, changing the way the user and Redstone can interact with the world. In this video, I'll be giving a brief explanation on how pistons work, so anyone can master the art of the piston without thinking too hard about it. Pistons are composed of a head and a base, which can't be separated without cheating. When placing a piston, they will always face towards the player, and shown here are all of the different ways a piston can look in the game. This structure is a somewhat complex example of pistons in it. When I flick the switch here, these 6 blocks of stone retract, letting water flow from above where the piston releases it. When I hit the switch again, the blocks expand and the water slowly stops. To figure out how something like this works, let's start with the basics. When redstone is wired up to a piston directly and powered, the piston will expand. Likewise, when not powered, it will retract. Over here you can see that when a redstone circuit is wired in between 2 pistons, both will expand or retract at the same time. However, this won't work with any more than 2. A problem with pistons is how to make a piston pull an object, not just push it. This piston, when activated, will push a stone block up, and when retracted, the stone will still hang up there in the air. There are 2 solutions to this issue. First, you can just use only gravel or sand, which naturally falls back down. But let's say you want to push things horizontally, or don't like only using 2 block types. That's why there's the sticky piston. The recipe for sticky pistons is nearly identical to the regular piston, but includes a slime ball. And as you can see here, the sticky piston pushes the stone block up and can pull it back down. Already with this basic knowledge, it's easy to make a simple structure like a 4-block piston passageway, pulled by sticky pistons. But when trying to make more complicated designs with redstone, a fundamental error rears its head. Most redstone addicts know that, when powered, a redstone circuit will only hold a charge for 15 blocks. The redstone wire here at the corner is number 15, and the rest of the spiral is left unpowered. Just like with the sticky piston dilemma, however, there are 2 solutions. First, you can just cut corners. Forget about the elegancy or design, just try to make things compact. But it's pretty simple to tell where this solution won't work. That's why there's the redstone repeater. Using a redstone repeater will renew the redstone charge, as if you flipped a lever exactly where the repeater is placed along the redstone line. Repeaters are also useful, because they can cause a delay, allowing the user to create a loading bar scenario. Here you can see the redstone wire doesn't completely light up all at once. There's a little delay where the repeater is activated. Also, here's a more exaggerated example, if you can't understand it. One of the more popular uses for pistons is to create hidden doorways. Looking in front of me, it's nearly impossible to tell from this angle which spot will open up. Let's take a look. Now, hitting this switch opens the second doorway, but the problem with the 3x3 passage is the middle block. It's extremely difficult to remove without overwhelming the area with redstone. So, instead of focusing on that, let's see how we can make a normal double door. The first obstacle here is how the sticky piston reacts when pushed. Unfortunately, when pushing a sticky piston, the block it is holding onto will not be affected at all. Easy fix though, let's just make 2 sticky pistons push both the block and the piston below it. Now let's figure out piston doorways. Looking here you can see a really simple 8-block door. When I hit the switch, the pistons simultaneously push or pull all 8 blocks. This is nice, but it's useless if you want something truly hidden. Let's move. Taking a glance over here, try and figure out what blocks will be moved when I hit the switch. Ready? It was a trick question. This lever is hooked up to 2 redstone paths, one that makes 2 sticky pistons push forward 2 cobble blocks, and one that pushes or pulls back all 4 blocks. This design, even though it is in essence simple, is tricky to figure out at first, but with a little bit of work, it's not hard at all to recreate. Now before I leave, let's take a look at some other neat piston uses. This is a piston escalator that pushes the user up onto a platform a few blocks above. Pretty neat, and all it takes is a lot of redstone repeaters in one switch. Here's an example of a redstone repeater cycle. It's easy to make a loop here, because when only one of these redstone wires is lit up, the charge is cycled through each repeater, causing the charge to never diminish. Okay, 2 more things, then we're done. As you can see here, by using a piston block to block a water flow, it's now foolishly easy to make dams, or a little waterfall, like my initial example at the beginning of this video. Finally, make sure not to forget about redstone torches. Along with a lot of other features, one of the most important things in my opinion is that when a button is placed on a block and an activated redstone torch is on the same block, the button will turn off the torch and any wiring that is wired up to the torch. Now you can make a button retract pistons, as in a button to reveal a hidden doorway, instead of extending all the pistons. Alright, that's it. Thanks for tuning in, as always, and make sure to subscribe and tell your friends. See you guys later, and feel free to leave any questions below about redstone or pistons.